Okay, so today we are going to look at the cosine function. So this is the second part of the sinusoidal functions chapter. We started with sine function, now we're going to cosine function. And the only difference between a sine function and a cosine function is where it starts. So remember, if we go back to our unit circle, remember that any point on that circle, so we pick any point, the point there, the coordinates are cos of theta and sine of theta. Theta being measured from the polar axis. So if we had an angle of 0, theta is equal to 0. So if we have 0 here, cos here, and sine here, a quick little table. If we had an angle of 0, this is 1, this is 0, right? And if we go all the way around and we get to 180 on the other side, we get -1 and 0. And then right in the middle, 90 degrees, we have 0 and 1. Okay? So when we did our sine function at an angle of 0, we started at 0. Now we're starting at 1 and going down to 0. Okay, so instead of going, here's our sine graph. Our sine graph went like this, starting at 0, go up to 1, and then back down to -1. That was our sine function, right? That was our sine function. So our cosine function would start at 1, go down to 0, down to -1. So it would start at 1, go down to 0, go down to -1, and back up. Now, so because one complete cycle is returning to where it started from, it would, at one period, it would end up there. So you would go, boom. That is our cosine function. Okay? So one way you could look at it is starting point. An easier way to look at it would be a horizontal shift. This graph is getting too messy. I'll redraw it, a clean one over here, and get rid of this circle. I'll leave the table there just so we can get a good reference point. So if we go over our nice table, boom, boom, 1, -1. So a full right? So that is 1.5 periods. One full circle, half a circle the other way. Now, a sine function in blue starts at here, comes back to here, goes to there. Halfway through, it's up here. Halfway through, it's down here. So, and then therefore again, on this side, it's back to here. So we go up, down, boom, and then same thing on this side. Halfway through is down here, boom, boom. So that is our sine of x. Our cosine of x starts up here, ends up here, and in between is at the very bottom. One complete interval. So in between, it's at the very bottom. One complete interval. So halfway through it's at 0, halfway through it's at 0, halfway through it's at 0. So it actually goes like this. Boom, 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 boom. Now you will notice right away that it is the same graph. This graph and this graph are the same graph. It's just horizontally shifted. So the difference between a sine and a cosine is a horizontal shift of pi over 2. Half a pi shift. Okay, so it's a 90-degree shift. Well, it makes sense. 90 degrees, we've got the opposite numbers. So if we take any sine function, so if a sine of x is equal to the cosine of x cosine plus pi over 2. Right? So if we're able to add pi over 2 to our cosine, we move it, oh, negative, sorry. no, I want to shift the cosine to the right. So that's right. Shift the cosine to the right to get sine. Right? Sine is the same thing as the cosine shifted to the right. This is important because everything else that we do with the sine function follows the same rules as, so everything we do with the cosine function follows the same rules that we've been doing with the sine function. The only thing you have to keep in mind is any problem that we encounter that deals with sinusoidal functions can be written either as a cos or a sine by simply shifting the starting point. Okay, so every single one, like the example we did last class about, which one was it? The fluctuation in three-toed sloths or whatever the case may be. If we simply take that equation and put that into our h, we've turned from a sine into a cosine function. Okay, so it's very, very quick introduction to cosine function because it's the same thing that we've already been doing.